Hey guys, it's Matt. Today's episode will be filled with colors. Indeed, I'd like to know more about that white light LED bulbs produce. How's it done? What's the process? And I realize that to answer that question, it is key to understand more about the LED technology. Today's expert is Mark Kessels, and he will lead our way.
As you may know, LED technology is truly fundamentally changing the lighting industry. But how is it done exactly? Well, it all starts with a wafer of dyes. The wafer itself is made of thin layers of semiconductor material, which are the core of LED technology. It's then cut into many small pieces of 1 square millimeter that we call dies or chips. The die is then encapsulated in a package. A package allows to direct the light and protect the chips from being damaged. You may have heard of several packaging techniques such as CSP, SMD or COB. Let's dive into that. A COB or chip on board has literally its chips being mounted on the board. A COB also has a large number of light-emitting diodes inside. It's known for its better efficiency and it is nicely distributing heat. However, it makes projecting the light more challenging. As the light-emitting area is very large, in optical applications like automotive headlamps, we want to have the source as small as possible, for it creates the sharpest beam with the longest range. And with a COB, it's impossible to recreate the optical fit for headlights. You may also encounter some lens-type LED packages with a dome on top of the chip. The dome itself increases the light output of the LED, but it also works like a magnifying glass. As you can see in this mock-up, when I remove the dome, the chip is much smaller, and the dome thus makes the LED virtually larger. And that's why we are not using either COB or domed LEDs for automotive lighting technology. Eventually, as LED packages are made smaller and slimmer, the CSPs have been developed. This goes for chip-scale package. And those packages are almost equal to the size of a die and offer higher flux, luminance and contrast ratio. And CSPs are, for example, also integrated in your mobile phone. Once the package is finalized, it's soldered to a carrier board that we call a printed circuit board or a PCB. Put simply, it's a board with an electric circuit included. When properly connected, the chips light up whenever the circuit is connected. SMD goes for a surface-mounted device. Those LEDs are the most common on the market. The LED is soldered on the PCB, which ensures a good electrical and thermal contact between the LED and PCB. These chips are our first choice when it comes to Philips LED retrofit bulbs. Our latest generation feature exclusive Lumileds Luxeon Altalon SMD LEDs. Specifically developed for front lighting at car makers, these chips produce a superior reliability, beam intensity and uniformity in color. This is where we intervene. We assemble the chip with some automotive elements, such as the heatsink, the burner, add a cable, the driver, and actually we created an LED retrofit light bulb. The LED retrofit bulb can be inserted into a headlamp and then into a car.
Wow. I mean, the making of an LED is a really complex process. But the good news is, we now have all the information we need to understand how that white light is produced.
Depending on the semiconductor materials used, LEDs produce different colors of light. For example, blue, green, or red. And by mixing the right colors, white light can be made. Another way to make different colors is by using phosphor materials, like this. Phosphor converts one color of light into another color of light. In automotive LEDs, we use yellow phosphor layer on the blue chip. As a consequence, when the blue light hits the phosphor particles, they glow and emit yellow light. This process is called fluorescence. Combined with transmitted blue light of the LED, it results in white light.
So white light is thus a mix of various colors. It can also be produced by combining red, blue, and green LEDs by varying the intensities. Thank you, Mark, for sharing these fascinating techniques. You now know, guys, everything. That's all for today, and I hope this episode will help you lead the way.
Innovation and you, Philips.